Okay, we got two variable statistics now. We're going to look at two variables, the year and CO2 level. We have data that was collected on the island of Hawaii on the top of the Mauna Loa volcano, they measured the carbon dioxide level since 1958. The data we're given is since 1984 to 2006. We're asked to make a scatter plot of the data, X versus Y, year versus CO2 level. We're going to do that on a piece of graph paper, although we can represent it on the TI-84. Just difficult to show that on an exam or evaluation of some kind. We're going to use the TI-84 to find the equation of the regression line, which is actually a linear model that will measure the increase in CO2 as a function of the year. So how do we do that on the TI-84? Again, we're going to use the stats key. So from your start screen, you're going to go stat, edit, and then you're going to put your data into list 1 and list 2. You have an option here. We could make it 1984, or we could make it the year since 1980 and go 4, 6, 8, 10, etc. Understanding that where this graph is displayed on the X and Y axes is going to be way out on the X-axis here, X-axis, out to 2006 on the X-axis. So I'm going to do it using the year and not the year since 1984. So I'm going to put, or 1980, I'm going to put in 1984 for X, and then just start counting down by 2 years. And then you need to put in the corresponding value for the carbon dioxide level. Okay, I've finished putting in that data in the table, L1 and L2. And now I want to do a linear regression, so I'm going to quit out and go to the stat key and calculate. And then linear regression is number 4. So I can arrow down or hit number 4. And then my X data is in list 1, my Y data is in list 2. And I can go down and calculate the equation for the line of regression, given that A is actually the slope in front of X, mx plus B. This is the y-intercept, implying that at year 0 we had a negative CO2 level, which is of course impossible. That's just the way the linear model worked, because we had to project it all the way out to the year 2006. All right, this doesn't really tell me a lot. I can use it to answer the question here and put in 2005 for X and round these appropriately, but I'm going to try and use the calculator to do this instead. So first off, we don't really have an idea of how good our model is. To do that, we have to turn on stat diagnostics, which normally would be under the mode button. Down here you can see stat diagnostics near the bottom, and I went too far. I want to turn that on. I think I got it this time. Okay, so stat diagnostics are on. The other thing I might want to do is if I want to plot it, we talked about this before, turn on stat plot. So I'm going to turn stat plot on. Don't want a box and whisker this time. I want a scatter diagram, which that's just the dots. This will give me the some kind of line. I think I just want the dots. Go back to the first one. Just a scatter of all the data we have. Okay, and then go back to where we began and do the linear regression again. This time, I think I want to store the equation in the calculator so I can use it. I want to store it in the y equals key. So how do I do that? I go to store the equation as a y1. So I'm going to go to vars, y vars, and these are the functions. And I'm going to put it in y1, I said. Okay, now when I calculate it, it will give me the same equation, the same strange y-intercept, and now it will tell me how good my model is. Again, this is a positive r. That means that it's an upward slope. We can see the values increase in CO2. How much do they increase every year? Well, that's the slope, 1.6 parts per million every year. The CO2 level by this model has been increasing on planet Earth. And then I said this is a very good model, which means that the data points are very close to this line. So this is actually a small section of the curve that can be modeled by a straight line. Earlier years, it may not be a good model, but in our range of years, it's a very good model. Can I get the stat plot to work on this? Okay, if I look at the graph, I see nothing. Okay, that's with a regular window size, minus 10, positive 10, x and y. Zoom stat, does this help me? Ooh, pretty good. Okay, so I see, again, the window size has changed. The computer or the calculator helped me out and put me out in the 1980s to early 2000s. And it limited the range of CO2 also for the Y values. So it gave me a very good picture on the graph. And you can see how good the model is. All right, 2005 is out at the end of the graph, but it's still within our data. So I can use the equation to calculate the predicted CO2 level at 2005 by using that equation that was stored for me this time, because I stored it in Y1. So now I'm just going to put in 2005 for X. And I'm going to use the calculator to do that. So again, I just use the Y vars key, and I'm going to find Y1 of 2005. That's what the question asked. So what should have been the CO2 content in the atmosphere 2005? Okay, it should have been 378.05, although they measured a level of 379.7. So a little bit lower than was actually measured. So maybe the rate is increasing as the years go on, which is in fact the case. It's an exponential curve.